Good morning, ladies and gentlemen. I'd like to welcome you to this webinar. My name is Karim Bazabachi. I'll be the organizer for this session, and with me is our presenter, Richard Bailey. Just before we hand over to Richard, I'd quickly like to go through the tips to continually prevent COVID-19. Always wear a mask when out in public, wash your hands with soap or an alcohol-based hand sanitizer, avoid touching your eyes, nose, or mouth with unwashed hands, avoid close contact with people who are sick, cover your cough or sneeze with a flexed elbow or a tissue, then throw the tissue in the bin, clean and disinfect frequently used surfaces and objects. Richard, I'll give you an opportunity to share from your side.
Good morning, everybody. I thought what we'll do this morning is just rehash. This is a tech talk that I've done before, but it is something, and as many of you may know, that I am an auditor. I continue to be an auditor, and so what happens is we see lots and lots of installations, and we come across the most common failures, and time again, and this has been for years. The pipe support is an issue. It's not that we don't want to support pipes. It's just that it's a mission, and we tend to misunderstand the requirements of the standards quite a lot in terms of how much pipe support, and lose sight of what we're actually trying to achieve. So we're going to look at both drainage pipes as well as water pipes. And again, ladies and gentlemen, this is not an in-depth, exhaustive description of every single detail you need to know about bracketry, but it's just an overview and just a kind of a recap to refresh ourselves as to what we should be looking for, what we should be trying to achieve when we're installing a system, and how to go about achieving it. And so I've always had that notion that it's the best. The best way to try and understand why I'm doing something is to understand what it's trying to achieve when I'm doing it. So if I know that when I'm trying to bracket a pipe, I'm trying to stop water hammer, for example, then I know I've got a mission, and I know what I'm trying to do, and it makes the decisions I make a little bit easier. So I kind of look at it back to front all the time, if that makes any sense to you. So it's important for me to understand why we're trying to bracket the pipes. It's not just to look nice, although that does count, but it's functional. It's a functional requirement. So for drainage pipes, 10252 2/2 is what we look at, and of course SANS 10400 Part P is also a sister standard that we look at. And here's just a couple of pointers as to what the requirements are there. So the pipes that require protection from atmospheric corrosion require at least 30 millimeter clearance all round. So if you have a pipe that requires protection from the atmosphere, some sort of a pipe that can degrade or that can corrode, you need 30 mil clearance all around that pipe. Now, how often is that the case in a duct? You know that when we go to plumb a new building, architect gives us a nice little space to work in, which you can hardly fit a shifting spanner in. Now you've got to put a cast iron pipe in there, which needs 30. It's often very difficult. So that if you need to have clearance around it and you haven't got the space, you need to make noises about that and ask the correct questions. Whatever the fixations are, the brackets are, they need to be built in, nailed, or screwed into the building structure. You cannot have bits of wire tying it to a conduit or to another waste pipe or whatever, or to an exposed piece of reinforcing. That is not a bracket, and it is not a fixation. It needs to be built into, nailed, or screwed, and it needs to have been designed specifically to support that type of pipe. You need at least one support per story, and that is bare minimum. Remembering all the time that the standards are actually a bare minimum requirement. You can go over and above. Plus, you need to go and look at what the manufacturers require. Now, at least one support per story, but that is not the end of the story, excuse the pun, because there are minimum requirements for vertical and horizontal installations for various materials of pipes. So that's just the beginning of it. And then at least two supports between any two joints. So if you've got a length of pipe with a joint here and a joint there, you need two supports on that piece of pipe. And it needs to be adjacent to the joints. In other words, next to the joints. So Any two joints, at least two supports, and next to those supports. So here's a typical example of what's not right. That pipe has got zero support whatsoever. It's in some sort of that's not a duct. If you know what ducts are, that's not a duct. We can do a whole tech talk on what ducts are supposed to look like, what their function is, and how they're supposed to be accessible to workers. So there's an example. They need to be strong enough for pipe and contents and the shock loads. So especially when you're talking about 110 millimeter sewer pipe, and depending on the installation type, you can have quite severe loads on that pipe on a fitting, remembering that it's just a conventional or a normal sort of pull out or a push fit fitting, a rubber seal fitting. Sometimes they're installed in such a way that they actually can pull out. Sometimes they're installed in such a way where the UV can attack the PVC. It's the incorrect grade and it perishes and the whole thing falls apart. So the contents of the pipe itself, plus shock loads. And if you work out the literage, the contents of a full sewer pipe at times, and you're sending shock loads through it in terms of dropping 2 stories before it hits the foot of a stack, that sort of shock, it can be quite severe, and a piece of wire is not going to do the trick, or sometimes even those plastic PVC things is probably not going to do the trick. It must be appropriate to the pipe material. So for cast iron pipes, for example, you require cast iron, malleable iron or stainless steel type brackets. For plastic pipes, require either those PVC brackets, or there are metallic brackets as well. So it must be appropriate for the material. You can't go and use PVC brackets on cast iron pipe. Vertical plastic pipes in multi-story installations require metal holder bats due to fire resistance. So that's an important note to remember. If you're doing a multi-story thing, because you don't want the whole installation to disintegrate and fall down in a heap, you need the brackets at least to be able to securely hold each section of pipe. Even if there is a section of pipe which is damaged by fire, it's not going to melt the brackets off the wall and allow that pipe to fall to the ground. Here are the 2 tables in SANS 10252/2, or the 2 tables that pertain to this particular subject, table 20 and table 21. And you'll see in the left-hand table, I'm just going to circle it. Right at the bottom there is the distances that you need to kind of bear in the back of your mind when you are bracketing PVC pipe drainage pipes. The top row there is up to and including 50 millimeter in diameter. So that's 40 and 50 mil waste pipes. And if you're installing vertical pipes, you'll need a bracket every 1.5 meters. If you're installing them horizontally, that reduces to 600 millimeters. From 50 upwards, that includes 110 mil pipe, 75 mil pipe, etc. Vertically 1.8 and horizontally 1 meter. So we never see brackets at that spacing. It's always much less than that. And on the right-hand side, I just want to draw your attention to that highlighted section. And it says the pipe supports provided by the manufacturer for this particular system should always be used. We're talking about polyethylene pipes, low density and high density. And the closer supports are required for this particular type of pipe, polyethylene pipe, where it is carrying water at temperatures above 20 degrees. You must increase or should we say decrease the space between supports, because polyethylene is a memory type material and it will start to sag over time, and it will stay sagged. If you allow it to heat up and not support it properly, it will sag slightly, and it will remember that shape, and it will stay in that shape, and it will. So you need to support it more, and that includes the fusion type installation drainage systems that we're familiar with, the black one. And so it says to us, we need to use the manufacturer's support system, and we need to increase the number of brackets that we use. Okay. So there are a couple of examples of reasonably good installations, you'll see that there are supports adjacent to and between all the fittings. They are nicely spaced out, neat. Pretty much everything's in place there. This, not so much. It might look reasonably impressive, but trust me, if you start looking at it and thinking about the details of this particular installation, it's not so lekker. We're not only talking just about the supports, but there's a lot of other stuff going on which shouldn't really be going on there. But so this is a typical example of what a client, when a plumbing contractor comes and does a job, and the client looks up and he looks at this thing and he can't understand what's happening here because he's not a plumber, and he's reasonably impressed. He says, "Gee whiz, yeah, you've done lots of this and this. It's quite neat and this and that." In fact, it's quite terrible. So it's one of those examples where looks can be deceiving, and we need to just keep our, keep in mind what we're trying to achieve and the design process that should go into a drainage system. Yeah, again, okay, the design is also wrong, very wrong, on a number of levels, but including the way that these things join in. But there's no brackets, nil brackets, so that pipe is free to wander and roam and change shape and move and so on. Again, incorrect material, shouldn't be used for above ground drainage, but anyway, there it is. No brackets, not enough brackets. That pipe over there is definitely going to sag over time. They've got pretty bad connections there as well. Okay, water pipes. As I said, this isn't an in-depth, exhaustive examination. It's just it's an overview and a reminder as to what we're trying to achieve. So 10252, same standard, except it's stroke 1. It's the first part of the standard, not the second part. 10252 stroke 1. And it's got a subsection says provision for movement of pipes. So there must be, when you are installing pipes that must move, and this is particularly true in hot water installations, it requires that a pipe, especially plastic pipes, a lot of plastic pipes must be able to expand. Now, I must just at this point say that this isn't quite an idealistic, the thing is that the standard it assumes perfection sometimes. And so it assumes that we have installed a 30-meter run of pipe perfectly straight and with the perfect brackets and so on, and we haven't left any expansion loops, which is often not the case. We often don't install it correctly in the first place, so we've got a couple of loops and twists and turns in it anyway, and so the expansion contraction won't really matter. But it should be installed properly, and we need to leave space for expansion contraction. This is usually for bigger jobs, for bigger contracts where you've got engineers signing stuff off and you've got main water supplies running long distances. So there's got to be sufficient space for movement of pipes, and they've got to be sufficient length of tubing around a branch or a bend or whatever the case may be where you are trying to allow for movement. And you have to then allow for an offset or a loop. This you can find in section 8 of 10252 stroke 1. They will detail a number of ways in which you can allow for this expansion loop or expansion, the allowance for expansion, should I say, and contraction. And it'll take you through that, as well as the bracketry for it. Hot water pipes longer than 18 meters to allow for expansion. Okay, so let's get back to what we're actually talking about, is the bracketry and the securing of pipes, and why we are trying to achieve it is for prevention of certain things. First and foremost is water hammer. One of the primary causes of water hammer is loose pipes knocking against the wall, along with undersized pipes, which we know. But a pipe which is unsecured knocking against a truss or a beam or a wall or a ceiling board or whatever the case may be will make a noise. And if it's not secured, that's also a pipe that meanders along like a windy path. There is friction loss there that's going to occur. It's unnecessary. It's a waste of pipe. It's untidy. And so all these reasons for bracketry. Now, we will get to the table detailing what the distances are for water pipes and plastic pipes in particular. And by that table, you'll be able to see that here, there is just not sufficient brackets at all. It's something like 300 mil for 1/2 inch and 400 mil for 3/4 inch are the requirements. And you can see that this is just not the case here. So noise and water hammer to be kept to a minimum. These are the requirements in the standard. The holder bats themselves should or must be attached to the building structure. Again, a piece of wire or cable tie or something like that is not good enough. It must be nailed or bolted into the building structure itself. Appropriate material and type for the pipe, and that is something you'd find out from a manufacturer or common sense, and that must be able to withstand the expected loads, remembering hydraulic shock or water hammer in those pipes, remembering the actual weight of the pipe itself. And we all know what vibration does to any joint, any nut and bolt, anything. You can make it super strong. If you've got enough vibration and it's a certain frequency, it'll loosen that nut, that bolt. It will shake that thing loose. So we must be very careful of that. And of course, it must be corrosion resistant appropriately for the area or whatever the case may be. So you can't put a piece of mild steel wire holding a copper pipe in, you know what I'm saying. Okay, so here's a couple of examples of both good and bad, I guess, but this is good. There's more than adequate support there. You know that you just by looking at it, you know that structure is not going to move at all. It's there to stay. It's well laid out, thought, planned, etc. Talking of, these are the requirements for the bracketry of a water piping system for metallic and plastic. So metallic is table 1 on the lower left. And on the most common size of pipes that we are dealing with, we talk about the top row there, which is between 15 and equal to or less than 25 mil. So which includes for metallic pipes, it'll include 1/2 inch and 3/4 inch, or 15 and 22. And for a non-vertical installation, so anything that's not vertical, you can have brackets at 1.6 meter intervals, which is nice and far. So it's very, very reasonable, easy to install. And vertically 3 meters, which is also lovely. It's nice and far. So that's both 1/2 inch and 22 mil copper pipe. You can have a bracket every 1.6 meters if you're installing it in a ceiling. But now you look to the right-hand side and you look at plastic. You have the 2 top rows is what we're looking at. So equal to or less than 20 mil, which is your 1/2 inch plastic pipe. Non-vertically, that distance between brackets drops to 0.3 meters, which is 300 millimeters. Now, you don't even have trusses spaced at 300 millimeters. So if you want to run a 1/2 inch pipe perpendicular to a couple of trusses, you need to install additional timber to be able to install the brackets. So you're not only looking at the cost of the brackets, but you're looking at the cost of the timber. You're also looking at the labor to fit both the timber and the brackets if you want to install this thing properly. So when you go and plumb a new house and you get audited, I'm not going to say the word unfortunately, but perhaps some might think it's unfortunate that this is the standard that we have to audit to. This isn't a rule that we choose to make. This is what the standards require. And if we look at it and we see that there isn't pipe supports every 300 millimeters on a 1/2 inch plastic pipe, it's a failure. And that's just what it is. So, and you can see the vertically for a 1/2 inch pipe is 600 mil. So that's dead straight up or down. Likewise, for anything anything above 1/2 inch, but up to and including 32 mil, non-vertically, now that's horizontal, 400 mil. It doesn't increase by much, does it? So even like a 28 or 1 inch plastic pipe, they are asking us to put brackets at 400 mil intervals. Now that plastic pipe, especially if it's multi-layer, it's pretty rigid. You know, it's more rigid than, let's say, a polypropylene pipe, a fusion type pipe. But still, they don't differentiate between a multi-layer or a poly pipe. I'm not saying polycop, I'm saying polypropylene. You do get nice polypropylene fusion fittings, fusion systems. So they don't differentiate. So any plastic pipe, 400 mil, non-vertically, and vertically 800 mil. So those things are very close together. those brackets, and they are never that close together in real life. So they are always going to be failed. and that's the unfortunate part about it. So, and it's not the auditors being pedantic. That's what the standards require. So this is what we're trying to avoid or prevent. Okay, so these are typical installations. Trust me, we find this every day. This is not something that took 100 years to try and gather 10,000 photographs no, this is common. So this is what we find. Brackets that are simply not suited for purpose. They allow for movement. They allow for damage of the pipes, whether that's electrical or mechanical damage, electrolysis, corrosive, whether it's a physical nail that's been bent and kinked the pipe. If the brackets themselves do not allow the pipe to stay straight, you have sagging pipes, which means that you have settlement of sediment. And believe it, there is a way in which you can actually block a pipe just by having years and years of sedimentary settlement in a little bow of a pipe. And you go after 10 years and you cut that pipe in half, and it's half full of sediment, and you've blocked the flow of that pipe. Noise because of changes of direction, unnecessary changes of direction, as well as loose pipes. All of these things is what we are trying to prevent. TP discharges, think about a blockage of a TP discharge. If that thing's going uphill, or you don't have enough supports, and it's a serious bow, and the TP discharge is in fact excuse me. So if a TP discharge is in fact open on the outside, it's a perfect little hole for insects to get into. Don't laugh. It happens. Spiders, wasps go and make little nests in there. And if you've got a bow in that pipe, it makes a perfect little space for a nest, or years of dust and debris settling in that little bow. And all of a sudden, when that thing wants to discharge, it can't, because it's blocked. And especially if it's got a backfall or something like that, or a bow in it, that is particularly dangerous. So I don't even have to tell you that this is not acceptable, yet sadly it is quite common. This kind of bracketry, this kind of attempt to secure the pipes to each other, or zero attempt whatsoever. Again, lots more wrong here than just brackets, but anyway, there it is. And here are some examples of good what you would want to see in a ceiling. If you get up into a ceiling, you look at this and you say, okay, all right, this is good. And now you can expect similar quality throughout the rest of the installation as well, which is exactly what you're trying to see. You can see there on the most of those pipes there you can see are 22 mil. On the left-hand picture, just to the right there, you'll see those T's are reducing. They go down to 1/2 inch to the right-hand side. But most of those are 22 mil, so those brackets will be 400 mil apart and nicely rooted against a piece of timber. Good, very nice, very neat. More of the same. So there's a fundamental difference between a system that has been thought out properly and rooted properly and bracketed properly. And this might seem like such an arbitrary subject, but you can see the chalk and cheese. And I'll go back a few slides because that is the last slide. You can see the difference just visually by glancing at that or that compared to looking at something like that. And the difference is not only visual, and it gives a good impression, but it is a functional difference as well. And it's something that is in the standards, is a requirement, and it is something that is continually being audited, and it will fail if it's not properly done. So with it, I'll say thank you very much.